Here's the solution to this Turing puzzle. So in fact, you can see that it is possible to cycle through the entire graph, visiting each node exactly once and coming back to your starting point. Now, remember that our previous Turing puzzle, the one where we had to cross each link or edge once, was called an Eulerian path. This one is called a Hamiltonian path because Hamilton, the same one who you may have heard of for inventing the so-called Hamiltonian in physics and the quaternions, unsuccessfully tried to market a game where one player would choose the first 5 steps of this path and the other player would try to complete it. Now remember that Euler let us skip the search process completely. For Eulerian paths, crossing each link exactly once, he gave us a simple criterion which lets us figure out whether a tour is possible, whether the number of edges at each vertex is even or odd. And that means that you don't need to search at all. The funny thing about the Hamiltonian path, where we're visiting each vertex exactly once, is that as far as we know, there's no way to avoid some kind of exhaustive search. So as far as we know, there is no insight, no simplification analogous to Euler's, which lets us cut through the search process and immediately see whether a solution exists or not. Instead, we have to do something like this. We have to pursue a tree of possibilities where we follow a path, we have a couple of choices, we try one of these choices and go down to one of the leaves of the tree. We either find a solution where we visited every vertex or we get stuck. Then we have to backtrack and try a different branch of the tree. But this tree is going to be enormous. If there are n nodes, and if roughly speaking, every time we enter one, there are 2 ways to leave, this is going to take the nth power of 2, 2 to the n time, 2 times 2 times 2, n times. And if n is 100 or 1,000, this is an astronomical amount of searching to do. So one of the goals of theoretical computer science is to understand when we have to do this kind of brute force search, which will often take an astronomical or exponential amount of time, and when there is some kind of insight, like Euler's, that lets us skip it.